In this session, we'll derive the equation for power angle equation for the salient pole type of machine. We know that the complex power, it is a comprised of active and reactive power, that is represented by Sg, that is equal to Pg plus jQg, where Pg is the active power, whereas Qg is reactive power. Sj is the total, the complex power. Then what we restricted is the active power, that is the first part of the complex power, that is a Pg. Pg is nothing but it is an active power that is given by Vi cos phi. Note that because of I is defined positive out from the machine, that is the direction of the current which is deliver the current, then equation 1 defines Pg and Qg positive. If the Pg and Qg are positive, that is in the case of generator. Note also that the equation gives per phase values of a power. Whatever you are doing all these calculations, that is the power angle equation per phase. Then if you want to convert that into a 3 phase, just you have to multiply with 3. Okay. Start with the Phasor diagram. We know that in the case of a salient pole or a two reaction theory, we have our 2 axis, d axis and the q axis. Then I am arbitrarily choosing the voltage V and considering the lagging power factor. Then I will draw the vector I lagging V by an angle of phi. Then I am resolving this V into two components, one along the q axis, the other along the d axis, that is VQ and VQ and the VD. Similarly, I will resolve the current I along the q axis and the d axis. Their components are IQ along the q axis and ID along the d axis. Then we know that the voltage, the total voltage induced in the case of the salient pole, that is, it is a sum of the terminal voltage V. Then we are neglecting here IRA drop because RA is very small. To V, you have got two reactances. One is XD, the another one is XQ. That is, you have to add ID XD drop and IQ XQ drop to V so that we get the generated voltage. At the same time, we know that the main flux is acting along the D axis, then your generated voltage will fall on Q axis. Means if you are adding to the terminal voltage IDXD plus IQXQ vectorially so that we will get E, that E should be all along the Q axis. Just you have to see here. First to V, what I am adding is IDXD, because we know that E is equal to V plus IDXD plus IQXQ, it is a vector. First I added here IDXD. To IDXD I have to add IQXQ. How we have drawn this IDXD? The IDXD should be perpendicular to ID because it is reactance drop. Therefore, the IDXD should be perpendicular to ID. Therefore, to the tip of V I drawn the IDXD which is perpendicular to ID. Then to the tip of IDXD I have to add IQXQ which should be perpendicular to IQ, which is perpendicular to IQ. Therefore, I am adding here IDXQ so that the factor sum of V plus IDXD plus IQXQ, what I am getting is the value E, that is the generated voltage. And we know that is the angle which is between the terminal voltage V and the generated voltage E is called as a load angle delta. That is, it is a D, a delta is the angle which is between V and E is called the load angle, or it is also called as a torque angle. The another angle I am defining here, that is angle between I and E, that is beta. Of course, between V and I we have got the power factor angle phi. There are three angles here, that is a delta, it is an angle between V and E, angle beta which is the angle between I and E, whereas I is the power factor angle, which is angle between V and I. Okay. With this help of this factor diagram, I want to derive the equation for Vi cos phi. How we have to do that? Means how we are deriving the power angle equation for the serial power. First, what you have to do is you have to draw the vector diagram by taking into consideration. Once again, I will repeat, that is V I. Then you have to resolve phi into two components. Then I am also, that is also resolving into two components. Then I am adding the IDXT to V, then IQXQ, so that I will get E. Then I am defining the different angle between V and E, I and E, and V and I. From the phasor diagram, what is the value of E then? That is, value of E is, okay, that is, I am from the phasor diagram, what I am doing is I am resolving V into two components, that is VQ and VD. How we are getting this formula, just I will explain in the next slide. That is, I am getting the two equation, that is E minus IDXT is equal to V cos delta and IQXQ is equal to V sin delta. That is, if you are taking this triangle, that is, I am showing in the next slide itself, that is clear cut. I am taken the separate from the, I am extracting from this. Also, from the same vector diagram, I am defining the value of IQ and ID. IQ is equal to I cos beta and ID is equal to I sin beta. How I am getting this? Just an angle phi. You can see the angle phi is, this total angle is beta. This angle is phi, this angle is delta. If you are expressing phi in terms of beta and delta, it is beta minus delta. Then how we are getting this equation number 2, 3? That we will see now. That is, first I am extracting from the V. I am resolving V into two components, that is VQ and VD. At the same time, if you look into this, from this triangle, that is this triangle, if you are taking this triangle, in that case, I am writing the equation first. I am resolving this. I am taking the cos function, cos delta. What is the cos delta? Cos delta is, that is the adjacent side. That is the adjacent side. What is the adjacent side? That is VQ. That is a VQ. Okay, divided by hypotenuse. That is, what is the hypotenuse? V. That is VQ by V. VQ by V. However, what is the VQ from the, in terms of V? It is a V cos delta. Is it not? It is the adjacent side divided by hypotenuse is a cos delta. Therefore, VQ is equal to V cos delta. VQ is equal to V cos delta. Therefore, I am writing here V cos delta. That is, this is VQ. If you are applying the cos function, what I am getting is, it is VQ is nothing but V cos delta, whereas this is your V sin delta. Because if you are applying a sine function here, it is opposite side divided by hypotenuse. Therefore, opposite side is our VD. Therefore, VD is equal to V sin delta. Then V cos delta is nothing but VQ. Then from this figure, this vector diagram, what is this total vector? The total vector is E. Then in total vector E, if we are deducting IDXD, then what I am getting is VQ, that is nothing but V cos delta. Therefore, in the left hand side, what I have written is the VQ is nothing but it is E minus IDXD. So that I am writing here E minus IDXD is equal to VQ. VQ is nothing but from this triangle is V cos delta. Similarly, this is opposite side is V sin delta. It is a V sin delta. This is nothing but, you can see here, this vector is same as this vector, that is nothing but it is IQ XQ. Therefore, I am left hand side, I am writing this as IQ XQ must be equal to V sin delta. So that I am getting the equation number 2. This is from this vector diagram, the same main vector diagram. Then similarly, I will take a current. I am resolving into two, IQ and ID along Q and D axis. The angle between I and the Q axis I defined as beta already. It is extracted from the main vector diagram. In that case, this is once again adjacent side, and this is, it is nothing but, it is opposite side. This is the hypotenuse. Once again, you have to apply cos and sine function for this triangle. Then what we are getting here, that is, if you are applying cos beta, it is adjacent side. That is nothing but IQ. IQ by I is equal to cos beta. Therefore, IQ is equal to I cos beta. Similarly, this is your ID. Then it is opposite side divided by hypotenuse, that is equal to sine beta. Therefore, ID is equal to I sin beta. I am getting equation number 2 and 3. Then of course, phi is beta minus delta, that we have seen in the previous slide. Therefore, we are getting all these the data. Then what I am doing here is, I am starting with this particular phi is equal to beta, but beta minus delta. Phi is equal to beta minus delta. I am taking the last equation. I am taking the cos function on both sides. Then what I am getting here is cos phi is equal to cos beta minus delta. That if you are expanding, it is cos A cos B plus sin A sin B, thus cos beta cos delta plus sin beta sin delta. Then just I am multiplying on both sides with I, so that what I am getting here is I cos is equal to, it is I cos beta cos delta and I sin beta sin delta. Just I am highlighting here I cos beta and I sin beta. What are these quantities that we will see here? What I did, just I am taking phi, taking cos on both sides. I am expanded that both sides I am multiplying with the current I. Then I am getting cos beta cos delta I sin beta sin delta. Then this I cos phi is nothing but I cos beta is nothing but IQ, that is already derived, and the I sin beta is nothing but ID, that is already, it is derived here. That is I cos beta is ID is nothing but I sin beta. Same thing I am substituted here, that is I cos beta is IQ and I sin beta is ID. Then I am interested in the active power Vi cos phi. Just what I have to do is, instead of I cos phi, just I am putting this right. What I want is Vi cos phi. Therefore, in the place of I cos phi, just I am substituting this. Then what I am getting is V into bracket IQ cos delta plus ID sin delta. Then we know that from the second equation IQ xq is equal to V sin delta. From that I am finding out what is the value of IQ. What is IQ? IQ is equal to V sin delta divided by xq. The same thing I am deriving. The another equation, that is E minus ID xt is equal to V cos delta, that also we are derived from the voltage triangle. Therefore, from this I am calculating the value of ID. The value of ID is E minus V cos delta divided by xt. Then in this equation I am putting the value of IQ and ID, so that I am getting the PC. Okay. Therefore, in this I am putting here, I am starting with VIQ cos delta plus ID sin delta. In IQ and ID I am putting the value of IQ and ID, that what I derived in the last slide, just I am substituting here. That is ID is equal to, you have to substitute V sin delta by xq. ID is equal to EV cos delta by xd. I have to substitute in this equation. Then what I am getting, that is instead of IQ, that is what I am getting is, here it is a V sin delta, P sin delta by xq, P sin delta by xq. Then cos delta is as it is. Instead of ID, I am putting EV cos delta divided by xd, that I am substituted here. Sin delta is as it is. Just to further, if you want to simplify, then V into V, that is V square, it is sin delta cos delta by x cube. Then V is multiplying here, and also we are breaking this term into two, that is one is EV by xs sin delta, EV by xd sin delta. Then the another term is V square, that is minus V square sin delta cos delta divided by xt, that is minus v square by xt sin delta cos delta. Further, if you are simplifying this, what I am getting is I am taking this as a first term, that is ev sin delta. Then the second and the third term I am writing as it is, v square sin delta cos delta by x cube minus v square by xd sin delta cos delta. In this, the second and third term, I have got a v square sin delta cos delta is a common. Just further, if you are simplifying, taking v square sin delta cos delta from the second and third term, what I am getting is it is 1 by x cube minus 1 by xd. That is this equation what I am getting here. Further, I know that sin delta cos delta is nothing but sin 2 delta by 2, that I am replacing here. Therefore, the power angle equation for salient pole machine has become EV by XT sin delta V square by 2, because I am converting sin delta cos delta into sin 2 delta by 2. Therefore, that 2 is appearing here, V square by 2, 1 by x cube minus 1 by xt into sin delta. It is watts per phase. If you want 3 phase power, just you have to multiply the whole term with a 3, so that we are getting a total power. Then if you are observing this particular the equation, that is EV by xt sin delta, the second term that is actually the first term is dominating, that is delivering the power. The second term is the saliency term. It is because of the salient pole this term is existing. Therefore, this power is also called as, it is the saliency, the power, that is also called as reluctance power. It is also called as the reluctance power. Therefore, suppose if the saliency is not there, means xd is equal to xq is equal to xs. If you are substituting xd is equal to xq, in that case this term has become 0. Therefore, what we are getting is p is equal to e minus v divided by xt into sin delta. It is same as your non-salient pole, the power angle, the equation. This is how you have to derive the equation. It is very simple. Start with the basic equation of vi cos phi. Draw the vector diagram. Then resolve v and I along d and q axis. Making use of the identities, just you have to substitute in vi cos phi, so that we will get this power angle equation. Then we will have the power angle curve. There are two terms, that is the first term and the second term. First I will draw the first term and the second term, then I am combining first and second term, so that I am getting the total, the power angle curve here. We can take along base axis is d and p. First I will draw the first term, because it is sine function, it is ev by xt sin delta. This is the first term. The second term has got sin 2 delta, it has got double the frequency of that the first one. Therefore, it is making 2 cycles when the first term make 1 cycle. Therefore, this is the first term. Then the second term is having the 2 cycles in the half cycle of the first one. Then this term is your reluctance power. That is what I am calling this. It is a reluctance power. If you are adding these two, then you are getting the total power. Therefore, we have to superimpose these two the graphs, so that what I am getting is resultant power p versus delta. Then here we are getting a maximum value. In this case, the maximum power delivered, what we are getting is, it is for less than 90 degree. This is your p max. Okay. Then we know that setting xt is equal to x cube, then you are getting ev by xs into sin delta. This is how you have to derive the equation for the power angle equation of the salient pole type of alternator, and you have to draw the graph.